Hello, and welcome to the session. Today we are going to talk about serverless testing. First, who is already using serverless? Okay, and who thinks that testing is really easy with serverless? All right, so the aim of this talk is to convince you that serverless is great and serverless testing is not hard or not as hard. Let's dive into it. So yeah, thank you so much for coming today. My name is Max. I'm working on the serverless team at Datadog, and I'm newly a Rust YouTuber. So if you want to look at what I'm doing, you can scan this QR code. I have already 500 subscribers, so I'm definitely into the YouTube game. So yeah, first, what is serverless? So it's kind of hard to define. Everyone has a very different definition for serverless. So let's stick with the AWS one. Serverless is building and running application without thinking about servers. So it basically means that you ship code and code only, and AWS or other cloud providers, but today we mostly are going to talk about AWS, is taking care of running your code, scaling it, updating security patches. You don't need to worry about infra. You just need to worry about code. And we will see in a moment that it's really powerful. You can only focus on what matters as a developer. It means like business code. So let's see a Lambda function. So a Lambda function, we will define it in a bit. But is a function as a service, so you deploy only the 3 lines of code. By the way, it's Rust, but don't worry, you don't need to be fluent in Rust today. So basically, you're defining an entry point handler, you receive an event, and you're resulting HTTP status code 200 and a hello world body. So great, this is very simple function, it's a hello world. But obviously today we are going to go beyond hello world. There is no point of testing hello world, or maybe there is, but we want to try to test like a real application. So what are you going to build today? By the way, I'm a huge pizza lover, so I don't know if you have ever heard of my demos before, but there's always some pizza in the demos. So today we are going to build 2 different HTTP endpoints, one to create a pizza and one to retrieve a pizza. And this will involve 3 different serverless components that we will define in a moment. The first one is an API gateway, second one is a Lambda function, and third one is DynamoDB, which will be useful to store and retrieve our pizza. And obviously we are going to test it. So first, let's go for a quick demo. Is it big enough? Yeah? Cool. Yes? So yeah, this application is already deployed, and I'll show you how it's deployed a bit later. But first, let's create a pizza. So does anyone have a pizza name to propose? Margherita. So let's create a margherita. Cool. Status code is 200. We receive a margherita which costs 10. 10 what? I don't know, but 10. And now we are going to retrieve this one. Margherita. And cool, we retrieve our pizza. So very simple application, but we will see that it will involve multiple moving parts, which are kind of difficult, maybe not to test. So let's go back to that. So the first component is an API gateway. So API gateway is a AWS managed service which maps route to service. So if we go back to this architecture, simplify architecture diagram, there is 2 different routes. One to post a pizza and one to retrieve. So here we have a choice whether or not we want to have 2 different Lambda functions to react to each one of those HTTP verbs. But for the sake of the demo, it will be only 1 Lambda function, and we are going to test whether or not it's a post on or get to an event. So API gateway will be responsible to map HTTP verb and a path to a service. Can be a Lambda function, it can be anything else, but today it's going to be a Lambda function. it's supporting REST and WebSocket out of the box. Today we are going to use REST, but if you want to use WebSocket, it's really useful to use that. It supports connection, disconnection events, really simple to use. And it has built-in authentication. Today no authentication, but if you want to do so, it's supported. Then we have the core components, the compute components where our code will be living. It's a Lambda function. So Lambda function is a function as a service. For instance, here it will receive an event from the gateway, post or get. This event will be processed by the Lambda function and result in something. It's an event-driven compute service, so it has to receive an event. Here it's an event from an HTTP gateway, but it can be a S3 event where you put something into a bucket. It can be a DynamoDB event. It can be a CloudWatch event. It can be a lot of different things, but today it's about HTTP gateway. And the first fun thing also is it's supporting any language. Any languages. There are built-in support from AWS for Node.js, Python, Ruby, Go, Java, .NET. I hope I don't forget anything. But if you want to bring your own language, you can. So if you want to do Rust, and that's what we are going today, you can bring your own language. So very useful. It's a piece of compute which will be triggered by an event. And last but not least, DynamoDB. So DynamoDB will be used to store our pizza. It's a fast NoSQL database. You can see that as a key value store, single-digit millisecond latency. If you operate into the same region, if your Lambda function is in US East 1 and you're trying to talk to DynamoDB in Japan, I'm not sure about the single-digit millisecond, but if it's the same region, AWS guarantees single-digit latency. And its high availability. I think it's 5.9, so it's quite high. So let's go back to the architecture diagram. The user is doing a HTTP request. This request will be processed by the API gateway. This API gateway will map the route and event to a Lambda function. Lambda function will detect whether or not it's a gate or a post and do some stuff in DynamoDB. So that's what we are going to build and test today. So let's see some code. Spoiler alert, this is not our final code, but let's have like a naive approach of the code. First, we need to handle the request. We need to have the table name. So here it's hard-coded. Then we need to load some config from AWS. Then we need to create DynamoDB client to create a pizza. Then we will create a pizza, which is a veggie pizza, which costs 10. Then we put the item into DynamoDB with a table name, price, and then we await that request from being completed, and then we return OK or connection refused. So basically, this looks like that if we want to implement that very fastly, but that's going to be hard to test, and we are going to see why. So first, we load the DynamoDB client, we create the command, and we send it. So let's test it with unit testing, because serverless and especially Lambda, it's a piece of code and you can unit test it. So let's do that. But you need to remember that it's not because we are using serverless and it's really easy to ship code to a Lambda function that we should not respect best practice. So you may be aware of a solid principle. I think the keynote this morning was talking briefly about that. So let's have a look at those five principles and maybe just look at the first two, for instance, today. First is single responsibility principle. So it means that your function should be responsible to do one thing, or your class, it depends of the language. And for very important principle, I don't want to overflow with information today, but if you are really curious about Solid, I will really suggest you to read more about Solid principle. So remember, the first one is single responsibility principle, and let's go back to the code. First, we hard code the table name. Then we load the DynamoDB client. Then we create a pizza. So it's already 3 different concerns. Then we send it, and then we do some error handling. So if we want to test that, that's going to be super hard because, for instance, the table name is hard-coded. So if you want to test on different environments, this is not going to work. Then you load the environment, the config from environment variable. Once again, if you have 2 tests running in parallel, environment variable might be shared, and this is not going to work. And maybe you don't want to actually send a pizza to a real DynamoDB. Or maybe you want, but let's see how we can fix that. So I will show you some code. And once again, it's Rust, but bear with me, it's not, you don't need to be a Rust expert. So first, let's define a pizza. So we have a struct with a name and a price. This is there are the 2 elements that we are sending to the REST request. It was margarita and 10, so price and name. And then we have a pizza manager. And pizza manager will have 2 different functions. So you can see that as an interface. It will create a pizza or get a pizza. And as you can see, there is nothing about DynamoDB here. The aim of this manager is to take a name and to retrieve a pizza. So nothing about DynamoDB. Then we can implement our manager, and in this example, it will be a DynamoDB manager. So if we create DynamoDB manager, then we will load the environment variable to create a pizza manager. There is also an option where we can pass the client as a parameter, and we will see that this is going to be super useful for testing, because it will be, we will be able to inject some configuration and not load that from environment variable. So this is one implementation of our pizza manager. But for unit testing, that's not super useful because we don't want to actually send a pizza to AWS, to a DynamoDB. So maybe we want to mock it. So here in the test, by the way, in Rust, it's idiomatic to have the test and the logic code in the same file. That's why you see that. And what we can do here is having a different implementation for this pizza manager. So here it's a mocked pizza manager, and instead of sending the pizza to DynamoDB, we're just hard-coding a dummy pizza, test pizza 10, and when we want to retrieve a pizza, it will return the same pizza. So the interface didn't change. We still have a get and a create pizza, but the implementation is no different. And this is, by the way, not tied to serverless at all. It's just that in serverless, we need to respect good practice of software engineering. It's not because it's really simple in the AWS console to hack a hello world function that we need to skip all those best practice in serverless. And then we have our actual test. So we create a mock pizza manager. We mock the pass parameter as well. So the pizza name will be deluxe. Then we are doing, we're making a request. So we're mocking the event. Then we handle the gets. We can handle get or post depending on the HTTP verb. And then we assert that the name has been test pizza, which is the name that we have here. So great. So there's 4 different tests. One for get pizza success, get pizza error, create post pizza success, and create post error. So let's run it and see how it goes. Great. I have 4 tests running. To be honest, I've just run it, so let me do a quick modification to show you that it's not all fake. So 4 unit tests has been running. I don't know why it's blocking. Maybe because my IDE is, yeah, okay. Cool, it's now passing. So I have 4 unit tests. Let's have a look at the test coverage. So this script is just running some some command just to, it's kind of verbose in Rust, but basically it's using grcove and open a HTML file, so it's easy to read. So let's have a look at our coverage. Doesn't look super good. Let's have a look at the pizza file. Of course, we mocked everything, so we are not testing anything, to be honest. So, for instance, the implementation of DynamoDB, which is really interesting in our use case, is not testing at all. So we mocked most of the code. The pizza implementation is working, but basically what we really want to test is now mocked, and it's useless. So it feels good because we have 4 tests. It's good, we have mocked something, but actually it does not mean anything. For instance, I can go back to the code, and let's say my pizza manager, now the name is name xxx. I rerun my test. VS Code is compiling. My tests are still passing. So I just mess up with schema, with a database schema, but my tests are still passing because we are not testing this DynamoDB client. So basically, mocking in serverless with managed service does not mean anything. You just feel that's good, but that's not really useful. So let's go back to the presentation. What about DynamoDB? We need to test that, and that's why test containers are for. So test container is really useful to test managed services. Here we are going to spawn an actual DynamoDB locally because AWS is kind enough to provide a Docker image ready to use with a DynamoDB inside. Of course, it's not a real DynamoDB, but we will see that in a moment. But it will emulate a DynamoDB locally. So by doing that, we will be able to not mock our DB implementation anymore, but actually call DynamoDB, but instead of calling that to the cloud, we are going to call that locally. So let's go back to the code and modify that. I will uncomment that and explain it in a moment. So as you can see, I'm now importing test container and some models and class definition from the DynamoDB SDK. So now I will have one more test, which is test create get pizza. And the first thing to do is we're actually going to spawn a DynamoDB image locally with Docker. So obviously we will need Docker install locally or on UCI. And what we are going to do is, remember the pizza manager.new, the second parameter was client. So in production, we will likely to use AWS provided environment variable, but locally, we might want to inject a client. And that's super useful because this is what we are doing here. We are creating a client here, and the client is using a custom port, and this port is different for each invocation. So as you can see, we are getting the port from the Docker run command. So for each run, for each test run, it will get a different port, and then we can create a manager using this client. Then we call the create DB. So create DB is actually creating the DB from scratch. And then we are asserting the margarita, you see. We are creating a pizza margarita, and we make sure that the result is okay. So once again, we are spawning Docker image, which is a DynamoDB locally. We invoke it. We create custom clients to talk to that image, and then we are running our code. So let's go back to the testing phase. Need to save. So the fourth test are really fast, and then we have an error. That's so why we have an error. Validation. Oh, this is great because I modify the name here. That was not expected, but to be honest, that's even better. Now we know that if our database schema is not valid anymore, we have a failure. And now we have a fifth test, which is create get pizza, which is now okay. So next, obviously, we are going to see how the coverage has been modified. Running the test once again. Four first are mocked, and the fifth one is actually talking to a DynamoDB. And then it looks really better. So if we look at this, we handle the post, we handle the error. If we look at the pizza manager is actually tested for the some clients. This is for AWS, so we are not testing it. We are testing only the happy pass. So if the connection is refused, we are not testing that for now, but we can create a test to assess that. Now that everything is in place, it's super easy to test. So great. Now we have some mock tests, which are totally useless. We have some integration tests with an actual DynamoDB, which is great because we can now test the connection and the schema, for instance. As I just show you, if I modify the scheme, it's not working anymore. So now we are ready to push to production, right? Let's see that in a moment. Obviously, in this architecture diagram, there is the API gateway, Lambda, and DynamoDB, but there are some other components, such as IAM capabilities. For instance, your Lambda function needs some permission to write to DynamoDB. And we can't assert that by unit testing, nor integration testing. So now, actually, we need integration testing to do that. So now that we are confident that our Lambda code is working and the communication between DynamoDB is working, we need to actually deploy that stack to AWS to make sure that everything is working. But if we didn't have the Docker image, Docker Compose, and all those tests locally, it would have been very painful to create one line of code of Lambda, deploying it, hitting the test button, it's not working, going back to the dev environment. So by doing integration locally and unit testing, it's speed up the development process. So next step would be integration testing. So I'll show you a file, which is the serverless YAML file. So to deploy, there is a lot of different tools. There is the AWS CDK, there is AWS SAM, there is serverless framework. Here is a serverless framework. I chose this one, but feel free to use any tool you want, as long as it's automated. So let's see how this tool is working. You basically writing a very simple YAML file. This YAML file will be compiled into a CloudFormation template, and this CloudFormation template will be uploaded to AWS. It's very hard to write CloudFormation template by hand, so I would suggest not to do that. And the serverless framework will be clever enough to deploy only the diff. If you are adding some function, removing, renaming, it will deploy only the delta between the previous deployment and the current deployment. So let's have a look at this file. First is the service. Let me zoom. Service name, so it will be the stack name. This tool is cloud agnostic, so you need to specify the provider. It's supporting GCP, for instance. Obviously, it won't be a Lambda function, but cloud function. You need to specify the region, and I'm going to talk about that in a moment. Then it's the IAM role statement that I've just talked about. So the Lambda function would need to put item and query item. You can put a star, but basically it's more secure to restrict the scope of this put item to the resource that you need to interact with. Then it's the package. So the Rust code will be compiled and zipped into Bootstrap zip, and this Bootstrap zip will be the source file for your Lambda function to execute. Then you have the function. So once again here, only one function. Could have been two different Lambda functions for each HTTP pass. But as you can see here, we have two different events. Remember, Lambda functions are triggered by events. So here it's HTTP events. The first one is a get. The second one is a post. But you can attach more than one event to one single Lambda function. So very convenient. And then we have the pass parameter pizza name. Remember in the test we were mocking that pass param. And to be clean, we can inject some environment variables. So the pizza service demo name for the table name won't be hard-coded anymore, but fed directly from the environment. And finally, this table, you could have created it manually, but obviously infra as code, not infra because it's serverless, but like resource as code is maybe better. So here you can create your DynamoDB table right into the serverless framework. So let's run it. You can deploy it. It's going to take a moment, I guess. Actually, no, I've just deployed it, so no change to deploy. Deployment skipped. That's fine, because I didn't update the code since the last deploy. But a cool thing to do is you can do serverless info, and it will retrieve the endpoint that the serverless framework has provided for you. So for instance, here, two different endpoints, which will point to the exact same Lambda function, one for a get, a second one for a post. So once again, this is it's not magic, it's serverless. You just need to focus on code and like maybe 50 line of deployment code to bring the code to life to AWS, and everything is taken care of for you. So now we need to test it. Actually, I will show you directly on GitHub Action. I have one flow here. So what's happening here? First, we're installing Rust, because by default, there is no Rust on the GitHub Action. By the way, GitHub Action, if you're not familiar with it, is CI tool directly linked to your GitHub repo. You just need to write a YAML file, and I'll be back to that in a moment. It's step. So first step is checkout, then it's to use the cache for Rust, then it's to install Rust, and so on. I will go to that in a moment. But basically, yeah, you install Rust, you package it, you deploy, you run integration tests. And what are those integration tests? I've not talked about that, but I will in a moment. Then don't forget to destroy your stack, because what you want to do is create your stack, test it, and destroy. You don't want to pay for your stack if you're not using it. So basically, the life of the stack is 11 seconds, so not super expensive. And then if everything looks good, then you need to deploy to production. Let's have a look at one pull request I've did here. And for some reason, I didn't understand what was IAM permission, so I thought it was useless, and I removed it. So now if we look at the GitHub action, it's triggered automatically a new GitHub action workflow with the name of your pull request. Obviously, it has failed. And if we look at that, checkout succeed, install cargo, run unit tests because unit tests were running. And this unit test is also containing the 5th test, the create get pizza. So locally, the connection between your Lambda and the local DynamoDB container was working. But when actually deployed to AWS, it's failing. So instead of having like a 400 error, I'm having like a 502 bad gateway, which means that the connection between Lambda and DynamoDB could not have been established. Maybe we need a more explicit error code, but you get the point. So what's happening here? Rust is very convenient for that, but I'm sure other runtime would do that. It's integration testing directly in your code base. So what we want to do is to first retrieve the URL. So if we go back to this, as soon as we are doing a serverless deploy, so this is what I've just done locally, then we can create the serverless info, and serverless info will output this. And then we can hook or grep or replace or whatever tool you want to use to retrieve the temporary URL to call your integration test. So it means that at each run, a new stack will be deployed. This is definitely not static. It will be dynamically created by AWS. So then you need your test to be able to catch that to run actual requests to your deployed stack. So once again, this integration testing is really integration. So you're actually deploying that to your AWS account, you grabbing the URL and you fetching some URL. And then you just do cargo test, and this will invoke those two tests. So let's have a look at those tests. So first you need to retrieve the environment variable set by the CI to have the deployed URL. And then we can create a pizza, test pizza price 10. We are going to do a blocking HTTP request to our endpoint /pizza. We check the status, and same for get. So get and post, both success and failure. So very simple code, but just to assert that the URL will be fetched. All the code that I've shown to you today, it's available on my GitHub account. So if you want to have a look and go into details, feel free to clone it. Everything is here. You have the GitHub workflow. Obviously, the GitHub workflow would need some secrets, and you can do that by going to settings, secrets and environment variable, and you can set your access key and secret access key. I suggest you to create a specific user in your AWS console to do that, but feel free to do whatever you prefer. But this is super useful not to leak any secrets. As you can see, to deploy, we need to have access to an AWS access key and secret key. You don't want to commit that into your repo, so you better to use secrets from the GitHub action. And finally, just want to show you something that I think it's very useful, because when you want to actually test against a real environment, it's hard to reproduce. It's hard to make sure that everything has been provisioned in the exact same way. So one trick I'm using here is what is really looking like to your production account that's the exact same stack, but in another region. So the only thing that will differ between production and integration testing is a region that I'm deploying to. So for instance, in the test here, the region for test is US East 2. So if everything looks good, then I will actually deploy to US East 1. This is really convenient, so there will be no conflict name, because you can have the exact same Lambda function name, but not on the same region. So you need something to be different. It can be another AWS account, but you will need another set of credentials. Maybe it will make the CI more complex, but it's really up to you. Personally, I prefer to use region, but that's a personal choice. So yeah, once again, on a new region, you deploy your actual stack, you're doing integration testing, and it's working. So yeah, deploy, invoke, actual invoke, so actual HTTP request. We assert the status code and the body, and then we destroy. And if something goes wrong in your CI, you want to make sure that you destroy, because as soon as a step is failing, it's fail fast, so your entire workflow will be crashing. So make sure you destroy. The step would be no matter what, you need to destroy it. So if always it went through, it's up to you, and depending on the CI or or CD in this case that you're using. But I'm sure there is something similar with GitLab or tool like that. But make sure you destroy your stack, because obviously if you have like a heavily contributed repo, you can end up with thousands of stack every day. So that's not what you want to do. So yeah, before you go, using serverless does not prevent you from respecting good practices. It's really easy to deploy code to serverless, but it's not because it's serverless that you should not do unit testing, integration testing, and have a good CI/CD. Mocking is most likely to be useless. As I showed you before, the code coverage is very poor. It feels good, but it does not make super sense. Test container is a great tool to validate behavior without having to redeploy to AWS each time. It's great to have everything locally. AWS is providing a lot of different images. I know there's one for S3 as well, so if you're working with S3, you can do that. Integration testing is a must, because IAM permission or VPC connection or firewall or stuff like that you cannot really emulate locally, you would need integration testing. And obviously, this is only for 2 functions, but in a real-world application, maybe your application has hundreds or 1,000 even Lambda function. So automation is really critical. You don't want to deploy manually your Lambda function, test it from the console or something like that. So yeah, that's it for me. Thank you so much, and I hope I convince you that serverless is not super hard.